All right, let's talk about one of the most important building blocks in all of programming, the variable. It's this incredibly simple but powerful idea that basically gives our code a memory. It's what allows a program to adapt to a world that's always changing. So how does it all work? Let's find out.
So imagine you write a quick little program to tell you the time. You run it, and boom, it prints 7 a.m. in US/Eastern Time. Awesome, it works. But you probably already see the problem, right?
Exactly. The moment it turns 7:01, our program is wrong. An hour later, it's really wrong. A clock that's stuck on 7 a.m. forever isn't really a clock, is it? It's just a static piece of text. We need a way for our program to handle information that, changes.
And that brings us to the solution. To deal with values that need to change while a program is running, we use a concept called a variable. You can think of it like giving our program a little sticky note where it can write down some information that it needs to remember and maybe update later on.
So what is it, really? Well, a variable is just a name that we, the programmer, make up to point to a piece of information. The best way to think about it is like a labeled box. We give the box a name, say time, and then we put a value inside of it. The most important part, the real magic, is that we can swap out what's inside that box anytime we want.
And making one is super easy. It's just 2 steps. First, you give it a name. Here, we'll just call it time. Simple enough. Second, you use a single equal sign to assign it a value, like the text 7 a.m. Now this is key. In programming, that equal sign doesn't mean is equal to. It's what we call the assignment operator. It's an action. It means, hey, computer, take the value 7 a.m. and assign it to the name time.
And here's where it gets useful. From now on, whenever we use the name time in our code, the program doesn't just see the letters time. Nope. It looks inside the box we labeled time and sees the value we stored in there, 7 a.m. It's just a really convenient shortcut to the actual data.
But just remembering something is only half the battle. The real superpower of variables is right there in the name. They are able to vary. The values we put in them are not set in stone.
So let's say we start our day in the US. We're at 7 a.m. We've got 2 variables, time and time zone, holding onto that info for us. But then, let's pretend we hop on a plane and fly all the way to Nepal. Everything changes, the time zone, but for our code, that's no problem at all. We just assign new values. Now time points to 4:45 p.m. and time zone points to Asia/Kathmandu. Easy.
And this is a really important rule to remember. Once you update a variable, that old value is just poof, gone. The program only ever knows and cares about the most recent value you gave it. It has no memory that the time was ever 7 a.m. in the US. All it knows is that right now, it's 4:45 p.m. in Kathmandu.
Okay, so variables can store information, and they can update that information. Cool, but what else can we do with them? Well, we can start combining them to create much more interesting and dynamic results. Let's see how that works.
We can literally take our time variable, our time zone variable, and use a plus sign to stick them together with some other text, like the words in. When you use a plus sign with text in programming, it's called concatenation. It's just a fancy word that means linking things together in a chain. And check it out. Here's what we get. The program grabs the latest value from time, which is 4:45 p.m. Then it tacks on the text in, and finally, it grabs the latest value from time zone, Asia/Kathmandu. And just like that, we've built a full, meaningful sentence out of a few different pieces.
Now, so far, we've only been putting text, what programmers call strings, into our variables. But variables are way more flexible than that. They can hold all kinds of different data, like, for instance, numbers.
Whoa, okay, what is that giant number? It might look totally random, but it's not. This is actually how computers often keep track of time. It's the total number of seconds that have passed since a specific starting point, in this case, midnight on January 1st, 1970. So we can store this number in our time variable instead of text.
And this is so important, because the program's behavior changes depending on the type of data it's working with. Remember that plus sign? Well, it kind of has a double life. If the plus sign sees text on both sides, it just combines them, concatenation. But if it sees numbers on both sides, it doesn't just stick them together, it does math. It actually performs addition.
So what that means is we can now update our clock in a much smarter way. If you want to move the time forward by 1 minute, we don't have to figure out any new text. We can just say, take the current time and add 60 seconds to it. The variable updates itself with the new total.
It's simple, powerful, and way more precise.
So let's zoom out and pull all this together. We've seen that variables are way more than just a place to stash some data. They are really the key to making our programs feel alive, to making them dynamic, intelligent, and actually useful.
When you think about it, variables give our code 4 amazing gifts. First, they give it memory, a way to remember information like the current time. They give it flexibility, which allows it to adapt when that information changes. They give it the power to handle real-world changes, whether that's the clock ticking or a user typing something in. And finally, they provide context, which tells the program if a plus sign means join these words or add these numbers. Variables are what turn a boring static list of instructions into a living program that can react and change. They're pretty much the building blocks of memory itself. So I guess the only question left is, now that you know how a program can remember things, what are you going to teach it to do next?